All right, welcome back. This will be our last video, and I'm going to make this as quick as I can. So when it says SHC, that means specific heat capacity. So in terms of specific heat capacity, why is the slope of CD lower than AB and EF? So what that means, if you take a look over here, you see that with these here, this is like a sharp increase in temperature really quickly. So that means that with exposure to heat, it quickly rises to a temperature that is going to have it so that it will melt and become a liquid. And then over here, when it's a gas, it's actually very easy for it to be able to become even hotter. Their molecules are easily broken and can heat faster. And actually what's interesting about ice is that even though it's water, and it is a solid, but the thing is ice as a solid has a unique quality where the molecules in between the molecular bonds within the solid of ice are easily broken compared to other solids. So that's why it can heat up so quickly. Whereas with water, you'll see that this has a much longer length of time for it to be able to heat up, and it requires more heat. So greater heat, longer length of time to be able to heat up just by enough to turn into a gas. And we even see right up here, water has the highest, in this chart, the highest specific heat capacity. And that means that it just takes a lot more heat. And I do have a little video here that quickly goes through specific heat capacity, and it helps explain why if you go to the beach, why the water is so much cooler than, let's say, the sand. All right, now going back down here. And again, think of A, B, and EF here. We know that for a gas, the molecules, the molecular bonds between the molecules are easily broken, so it's easier to heat up faster. And same with ice. They have that unique quality where the molecular bonds within the solid are easily broken, and so it's much faster for it to warm up. So that's why they are very similar as far as they quickly heat up. All right, we're almost there, guys. Hang in there. Oops, too far. Okay, so here we just have it where there's a few different substances, and we go through their specific heat capacities and the latent heat. So here you'll notice that going to a solid to a liquid, it requires 334,000 joules per kilogram. And then going from a liquid to a gas requires 2,272,000 joules per kilogram. So it takes a long time. It takes a lot of heat, shall I say, for water to be able to warm up, to transition into the next phase. And just last little part here. So water is a truly unique compound. Among other things, it is responsible for energy transfer around Earth. So the properties of water make it possible for moderating climate in winter and summer. Without water, summers would be much hotter and winters much cooler. And so I'm going to have you think about this one. Why is it commonly 2 degrees Celsius warmer in the summer and 2 degrees Celsius cooler in the winter at the Kelowna airport than it is if you're right by Lake Okanagan? All right, I want you to think about that, knowing that water takes a lot more heat and it takes a lot longer for it to warm up, and compared to, let's say, air and whatnot, so, or even the land. Now, responsible properties, what we're going to do is just quickly fill this part in here. So water has high specific heat, and we also know that it has high latent heat. So it takes a lot of energy. To evaporate. There we go. I can spell. It takes a lot of energy to evaporate, and also transfers heat by convection. So That is our short unit right there on heat. We're going to continue building on this. Please let me know if any of this isn't making sense or if you need some things cleared up. I'm more than willing to help you. But you're basically having it where you're going from question or page 6 to, I guess, technically page 11, keeping in mind you obviously have quite a few pictures and graphs in there to help break it up. And fill in your notes, and then just have it where you're going to fill in the answers for the Google form for your homework check. All right, take care. Have a great rest of the day.